Hello and welcome back to Calero Academy. Today we will be looking at a simple trigonometric equation. We will then solve it, and then we shall do the main part of this video. The main part of this video will look at expressing the answers, the solution set to that trigonometric equation in a nicer way, a way that is more pretty. Okay, so the equation is rather simple. We want to find all x such that cos x is equal to sine of 2x. Now, there are multiple ways, of course, to solve this. We could expand sine 2x and then solve, but since that's not the main part of this video, we're just going to look at it one way. So, the way we're going to solve this is that we know that sine alpha is equal to cos of 90 degrees, or pi on 2 radians, minus alpha, for all alpha. So, what we are going to do is just now use that formula for sine 2x, and therefore we have that cos x is equal to cos of pi on 2 minus 2x. Now, since cos has two answers, there are two solutions in the unit circle to this. So we are going to be looking for two solutions, x sub 1 and x sub 2. So the first solution is easy enough. Let's name x sub 1 the solution such that x sub 1 is equal to pi on 2 minus 2x sub 1. So our first solution is x sub 1 is equal to pi on 2 radians minus 2x sub 1. However, this is not all the answers of this form. We always have to remember to add 2 pi n to our answers, because all the solutions to our dear cos and sine functions, they all repeat themselves in 2 pi radians, 360 degrees. And n, where n is an element of the integer sets. So we're just going to be adding multiples of 2 pi to our answer. Okay, so let's just simply add. We have 3x sub 1 is equal to pi on 2 radians plus 2 pi n. And then we have that x sub 1 is equal to pi on 6 radians plus 2/3 pi n. So that's our first solution. Now, what is the second solution to x sub 2? Well, we know that cos alpha is not only if cos alpha is equal to cos beta. We don't need to go into alphas and betas. So anyway, we know that x sub 2 and x sub 2 will be equal to 2 pi minus this stuff, pi minus 2 minus 2x sub 2 plus 2 pi n. And the reason for that is that cos of alpha is equal to cos of minus alpha for all alpha. So we can write, because upside down 3-dotted triangle, because cos of alpha is equal to cos of minus alpha. And so x will be equal to 0 minus pi on 2 minus 2x in brackets, which is the same as writing 2 pi minus that stuff. Because, you know that. So let's just quickly solve this. So x sub 2 is equal to 2 pi minus pi on 2 plus 2x sub 2 plus 2 pi n. Add to both sides. We have subtract x sub 2 from both sides, and then add this to the other side. Subtract this to the other side, and in the end we'll get that minus 3 pi on 2 is equal to x sub 2 plus 2 pi n. And it looks better to put the 2 pi n over on this side. So this is equivalent to say, it's equivalent to say that x sub 2 is equal to pi on 2 plus 2 pi n. And the reason we're writing pi on 2 instead of minus 3 pi on 2 is, of course, that they're equivalent because of the fact that cos and sine are equal to the 2 pi equivalent, so we can just add 2 pi to this and it won't change a thing. Where, of course, n is still an element of zeta. Of z, the integers. So, what do we do now? Well, we've got our x1s and we've got our x2, so these are the solutions. These are the solutions to our first equation. So, the second thing that we are going to do is try and see if there is a nicer way to write our solutions, so we can get all of our get all of the answers into one little compact little solution set. Okay, so what we have to do first is we have to write out what are the solutions to sets x1 and x sub 2. We write out x sub 1 is equal to pi on 6, 5 pi on 6, 3 pi on 2, and then so on. And ... and it will never end, of course. So these, of course, I'm not writing the negatives, and there's dots back there too for minus ends, for negative ends. And then our x sub 2s are equal to minus pi on 2, dots going that way too, minus pi on 2, minus 7 pi on 6, minus 11 pi on 6, and then so on back there, where I wrote the solution set backwards a little bit. So, if we mess around with that a bit, first let's take out the piles on 6. They're unnecessary. We don't have to have them in there. So we can, once we get out of the pile on 6, it'll be a little bit clearer that we can then rewrite our solutions as x sub n is equal to pi on 6 times 4n plus 1 and pi on 6 times 3 times 4n plus 1. So, this is not quite the compact thing that we want yet. And by the way, of course, there's a lot of steps in between here, but I will leave that for as homework for our Calero students to get to prove to yourself that this comes from those two. It is not too hard and should take less than 8 minutes, which would have taken a lot of time in this video to explain. So, this is not the perfect solution. We still have a dash in there, comma, which represents the and it is, although it's nicer than these two separate formulas, it's not the end product that we want. So, when we were solving this problem at the Calero headquarters, we tried two different techniques before we hit on the right one. So, how do we get one solution set to represent both this and this? Because look, let's forget the piles on 6 for a second. So if we write our n is equal to, let's put this up a bit, n is equal to, when n is equal to 0, 1, 2, 3, and then 4, 5, 6, so on, we have xn, and here we are forgetting our powers on 6s, we're just writing 4n plus 1, 4n plus 3 times 4n plus 1. So, xn is equal to 1, 3, 5, 9, 13, 15, 17, and then so on. How can we combine those? So, the reason it is hard to do is because these functions, 4n plus 1 and 3 times 4n plus 1, you cannot use 4n plus 1 to explain 3 times 4n plus 1 because they have different periods. This one is a magnitude of 3, has a period that is 3 times different to the other period, and thus it is very hard to put them together to get them to be the same, to express them as one single thing. So we tried to solve this using functions. For example, we can use the indicator function. We tried, for example, to let x sub n be equal to the indicator function, indicator with some stuff here, plus another indicator function. We tried that. The reason that doesn't work, along with something else called the mod, we also tried representing it in terms of mods. The reason that stuff doesn't work is that these things are a relation. If you plot it in, because remember, a relation in a coordinate geometry is not a function. A function is a relation, but a relation is not a function. A function is something that maps stuff from the x-axis to the y-axis. But there's no x value that maps to two y values. So, for example, this would not be a function. But it is a relation, because relations do not have that constraint on them. And it turns out that the solution to x sub n is a relation. Because, look, we are going to have doubled values at certain times. At one point, we will have it being equal to both this and this. So, a third of the values that appear over here will be equal to the values over here. 3 times 4n plus 1, 4n plus 1. Now, the reason that is important is that you cannot represent the both of them as a function, as the indicator function is, and the mod function is. So what we had to do is search for a relation that would work. And the one that works for us is plus and minus. Because plus and minus will give you two values for every x that you put in, except for 0. And that will give you a relation. And so, again, it would be rather tedious to work it out right in front of you, leaving it as homework for Calero students. X sub n is therefore going to be equal to pi on 6 times 8n minus 6 plus or minus 4n minus 3. And you can quickly check for yourself that this is the same, that this will give us the same answers as the previous answer up here, and that in turn, and of course that represents our two beginning solutions. And so this is of course a very lovely way to express our answer. No weird commas meaning ands. There's no two separate solutions entirely. So all in all, this is our end product, and we can now write in a little box representing our success. And thank you for watching this Calero Academy video. We hope you enjoyed it. If you have any comments, or if you are not clear about something, just put it down in the comments area. And if you would like us to make a video of something, also put it down in the comments area, and we'll hope to get to you if we can. So thanks again for watching, and goodbye.